So this session, we will start off with a very interesting use case from Lytx. Lytx is one of our AWS customers who successfully migrated their applications from SQL Server to Aurora for PostgreSQL Server. So first, Bhavesh will walk you through their use case on migrating their applications from SQL Server to Aurora PostgreSQL. And following with that, I will walk you through the standard best practices in migrating commercial database engines, such as Oracle or SQL Server, to open source, cloud-based managed services, such as an Aurora PostgreSQL or Aurora Postgres for MySQL. Okay? So with that said, before heading on to agenda, a quick introduction about myself. My name is Chandra Patiwada. I'm a database specialist solution architect focusing primarily on commercial to open source migrations. And Bhavesh, he's from Lytx. Over to Bhavesh.
Hey everyone, good to see you all here. I know we have a bit less presence, but I expected that towards the end of the day. So my name is Bhavesh Patel. I am from Lytx. This is I just started 5th year at Lytx. Very exciting times at Lytx. We are in the process of modernizing our architecture, entire technology stack. We are moving to the cloud, and for the most part, we are leveraging AWS managed services. So again, as I said, this is my 5th year with Lytx. I lead data engineering at Lytx. My team is responsible for ingesting, processing, and publishing data to several of our internal as well as external consumers through several different interfaces. So this talk is about how we, one of the specific use cases where one of our core applications, we migrated to basically a containerized application, and behind the scenes, we moved from SQL Server implementation to the Aurora PostgreSQL implementation. So again, this is the agenda for today. Chandra walked us through that. I'll just jump right into it. So this is Lytx. Lytx is basically into safety, driver safety, and fleet management. So what we do is we manufacture devices, all the way from devices to firmware that sits on the device to managing the data that we receive from the device. The big aspect is we do video monitoring as well. This is basically for safety and compliance reasons for big fleet management companies. So our customers are small fleet companies to mid-level to some of the larger fleet management, or we call them for hire carriers in several different countries. These are basic stats about Lytx. We are operational in almost 89 countries, very heavy throughput data that we work on. So today we'll specifically focus on, as I said, one of our core applications. So fleet and driver safety, Lytx is one of the pioneers in managing fleet and driver safety. So basically, our camera that we install, or our devices that we install in the vehicles, they are basically based off of machine vision and some AI capabilities within the camera that will detect various behaviors that are, various behaviors inhibited by the driver who's driving the vehicle. This is basically, implemented using machine vision technologies that we have within the cameras. What the technology detects risky behaviors, and it raises events, basically, which are published real time to the driver. So what we do is we detect the behaviors, right? If the behavior is distraction, then we alert the driver right there in the device. We have LEDs that are flashing within the cameras. We have audio alert that goes out. So driver has chance to correct the behavior right there. But let's say if there is a persistent behavior, and the behavior is carried on for certain times, certain frequencies, then we have a workflow that we go through, right? So basically, drivers are given a chance to correct their behaviors. If not, if the behavior is not corrected, right, our CAM flags those behavior as persistent behaviors. And basically, what we now do is, as we understand these behaviors, we go or we create events that goes through coaching workflows. In this case, now the driver is working with the coaches within the fleet organization, and they help them, correct the behavior, coach them to, correct the behavior, and that's particularly the workflow that we go through. Right? So we are at a stage where we have some of these technologies implemented, but obviously, as most of the organizations do, we are modernizing our architecture, right? Our goal is to go to 10 million subscribers in next 10 years. So it's a very aggressive goal. In order to achieve that goal, right, the architectures needs to support that kind of a growth, right? So just to give you an example, let's say there is a fleet of 10 vehicles, and every morning you have to go to your business, right? So every morning when you start your vehicle, the 10 drivers are driving your vehicles. And as soon as they start their vehicles, ignition on, we started capturing data from these vehicles, including the behaviors that are exhibited by the drivers, right? So in order to achieve the 10 million goal, we really want to start building our systems for growth, right? So the idea, or at least our approach, is to build scalable systems. Now, in order to build scalable systems, obviously, it is really hard to scale that in a data center or on-premise, right? I mean, we can do that, but it involves a lot of manpower and planning and obviously the spend as well. So the other aspects are, in order to achieve that growth, to compete with the market, we also need to build and deploy the features as fast as we can, right? So we really want a system that enables us for continuous delivery, continuous integration within our systems. We also want to start optimizing our resources, right? So basically, we cannot achieve this without moving to a scalable system. So what we are also trying to do is, in order to achieve continuous integration and continuous delivery, we are building more containerized applications. So current implementation is actually a bit of a monolith implementation, all the way from the application stack to the middleware to persistence. So now, since a few years, we have been refactoring our application stack to go more container-based. And again, we use AWS managed services for most part. This has been a very helpful environment, because we can scale our systems. There are so many utilities available. There are so many managed services are available within the AWS platform. And we have been leveraging almost most of those services. So as I mentioned, right, we are going container-based implementation. One of the core aspects is to move from a monolith persistence technology to a microservices data persistence technology, right? So what we have done is we have identified core domains of our business, and those domains are now implemented as microservice domains. Behind the scenes, we are now trying to move away from SQL Server technologies to a technology that is suitable for domain. For example, one of our core domain, apart from safety, is vehicle tracking, right? So we capture GPS crumbs every 10 seconds, every second, every 30 seconds. We have configurations based on which we collect these GPS crumbs. So earlier we saw, right, we have about 5,000 or plus implementations. That means that we have about more than 500,000 plus vehicles on the road per day. At a peak, we collect about 850,000 events. These are just the events. The GPS breadcrumbs are triple the size of this data that we collect, right? So in order to do that, we evaluated several different persistence technologies, and our So our main criteria is the heavy write throughput, right? As I said, there are data sets that are generated every second as the vehicle is in motion from ignition start to ignition end. Apart from driver safety, there are other data points that we also collect over the wire. Basically, it's a typical IoT scenario. So 850,000 behaviors identified a day at a peak, right? On the weekend, it's about 350,000, when the drivers are not that much on the road. Collect about 20 million records a month. That's our stats. And then obviously, as I mentioned, we are trying to go 10 million subs in another 10 years. So we're obviously going to scale these rights, right? So what we do is, as soon as we capture the event from the device or device notifies us of an event, we try to capture that data almost in real time into our persistence system. First entry point is obviously the Aurora PostgreSQL DB that we have been leveraging now. Apart from that, right, there is also a read performance. So most of our clients are interested in knowing, how their drivers are performing. And, typically we don't know, but, it's a liability for these companies, right? They basically, their business is as good as how their drivers are performing on the road, right? And how they are managing day-to-day operations with their vehicles. So reads also, we're looking for a high performance implementation. We have time series data, right? So as I said, when the vehicle starts moving, we capture data on a time basis, but the reads are also happening in the similar fashion, right? So for example, when a client looks at data, the first thing they look at is, okay, between this time and this time, or in these 2 trips, how did the driver behave? Or we actually, in order, let's say, for example, there is a bigger company, right? You have 500 vehicles. Now, it is very hard for, it is very hard to manage 500 vehicles on the road. So, typically what we do is we divide these 500 vehicles into groups, and each group is managed by the personnel that are attached to that group of vehicles. So the reads are basically on time-based and on the group that we categorize the vehicles in. Since this is a very heavy throughput data, we also want to make sure that the performance is optimal on our portals, right? Especially the driver portal and the coaching portal. So what that means is, we cannot accumulate the data into our transactional systems, forever. We have to figure out what is a good time to live for that data set on the application for optimal performance, right? So that was another critical criteria we considered when we evaluated the persistence technology. And obviously, right, the bottom 2 boxes are as critical. The high availability. We are a typical SaaS company. We have 5,000 plus clients. So high availability is very critical for the operations. And again, this is safety, driver behavior. So this data has to be always available. So these were also some things that we considered. In following slides, actually, I'm going to talk about how we compared this with our existing implementation. So at least, get an idea of why these things are important and why we considered these when we evaluated Aurora PostgreSQL in lieu of our SQL Server implementation on-prem. We'll keep the questions at the end, right?
Yeah, anytime you can. Yeah, maybe at the end.
Yeah, if you guys have anything, just let me know. Otherwise, I'll just keep going. So, after evaluation, after we went through the points I discussed earlier, we picked PostgreSQL as our implementation. Again, as I said, right, we have, since past 4.5 years, we have a very strong partnership with AWS. We work very closely with AWS teams in all of these implementations. So, it has been a very smooth ride, and this was, again, one of those instances where we had a very good use case and the solution was available that was very fitting to the requirements that we had, right? So obviously, PostgreSQL is one of the very known RDBMSs. It's open source. I mean, it's available. It's a very easy to implement, typical SQL implementation. So if you're, or if the team is aware of SQL-based relational database implementation, PostgreSQL becomes the right choice.
Yeah, Bhavesh, one second. You have a question, sir?
Yeah, question. Do you guys build the new system on Postgres or migrate from SQL Server to Postgres?
Yeah, so we implemented a new PostgreSQL instance in AWS, and then we migrated our on-premise SQL Server implementation to PostgreSQL implementation in the cloud, right? And we'll talk about that more in the coming slides, right? And again, the reason that we chose Aurora is because it integrates well with, all the other tool set within the AWS stack. So one of the requirements for us is, when we track these events, we also track the location of the events on the road where things are happening. It is important for the existing to understand, what the driver behavior, where things occur. And it also helps us understand these hotspots, right? Over the time, we collect quite a bit of data points, and we exactly know which areas we run into some of these events that are, exhibited by the driver. For example, one of the events we capture is rolling stops, right? So when the driver doesn't come to a complete stop on a stop sign, right? That's basically a flag for us, and we have to capture that event, send it to that. I mean, that is a very common thing in certain areas. So based on, the information we acquire, based on these events that we generate, now we can actually guide the fleets who are operating in that area on some of these hotspots as well. So this data capture is super critical for us. The other thing that allows us, PostgreSQL Aurora allows us to do is to scale, right? And as I mentioned, we are scaling, our operations to 10 million subs. Now, typically, right, in a day, during a peak hour day, we have, even that time, we scale our read performance quite a bit. The write performance increases as well. So the system is scalable. It allows us to scale, especially the read replicas for the read performance, right? We'll talk about that in the coming slide. So I mean, Chandra will go through the architecture as well, but again, the thing is that the data persistence itself is scalable, right? So there are 6 copies by default that Aurora maintains in 3 different AZs, right? So that itself, it gives us a good level of replication and reliability between the availability zones. Now you can scale this further to multiple regions, and you can, basically more reliability, more high availability scenarios that you can get into over the time. So this is how our stack is evolving, right? Again, I should say it is evolving as we speak. So on the left, we have our current implementation. So at the top, you see that Lytx dashcam. That's the actual dashcam that we have in the vehicles. And then the green LED you see is actually the alert that we send to the driver as soon as, we encounter a behavior using the Lytx machine vision. There is also an audio alert that goes out along with the LED alerts. In the current implementation, what we do is we leverage on-premise RabbitMQ cluster. That is the first entry point. So what we want to do is, as soon as the event is happening, or as soon as we get any data point from the device, we really want to land it first, and then obviously have the subsequent systems start working on that. So on the on-premise, we had RabbitMQ implementation. Again, this was all on-premise, so it's a clustered environment. Anytime we had either a big contract or a surge, we had to extend these servers manually, rebalance, and a lot of activities involved. RabbitMQ flushes the data into our OLTP environment. I'll walk over the OLTP environments in a bit detail in the coming slide. And then we also use SQL Server as our data warehouse implementation. So on the left, you see, right, it is a complete SQL Server environment, both on the OLTP side and on the data warehousing side, right? So we are migrating to a modern architecture on the right. As I mentioned earlier, it is all managed by AWS ecosystem. Instead of RabbitMQ, now we are leveraging managed Kafka, MSK service. Again, it's a huge benefit to go with managed AWS service rather than managing a Kafka cluster by ourselves. Again, same thing, right? We have some data which is generated every second, couple of billion records a day that funnels through our Kafka. And if you don't have system like that scales, we won't be able to handle the load, right? Both from the producing perspective as well as consuming. Even our consumers are implemented using Kinesis and some of the Flink technologies that are available within AWS ecosystem. So from Kafka, we do two things. We load that raw events into S3. So basically, if you think about it, right, on the left, we have a typical architecture where we persist the data in OLTP. We use SSIS to read the data from OLTP, publish it into the data warehousing environment. On the right-hand side, we are completely going microservices-based, right? So we are actually now following some microservices patterns as well. Event sourcing, CQRS are the two main patterns that we are following. So we really don't have any connection to the OLTP database when we have to get the data into our data warehousing environment. Everything funnels through Kafka. And both of the implementations, the OLTP, PostgreSQL, Aurora, as well as the cloud data warehouse, both are implemented using event sourcing from Kafka. The other thing that again, it's a high throughput environment. The reads are very important. So what we do is we leverage OLTP to only persist 3 years worth of data. Again, that view is sufficient for our clients, right, to see their day-to-day operations. But if they want a longitudinal view of the data, we always have all that data in the Redshift cluster. Actually, our application has now, the microservices application has some intelligence built in where if you are asking for 3 years worth of data, it will actually go to Aurora PostgreSQL. But if it is a longitudinal data requirement, it actually funnels that request to Redshift. Yeah, they are actually running in parallel for the time being. But we are very soon going to shift completely onto Aurora PostgreSQL. Exactly. So we keep them in sync right now, but we're very close to start shifting or shift this entire architecture. The left side is actually going away.
DMS?
What is that?
Is DMS syncing?
Yeah, I'll go through that as well. But you're right. DMS used to be our earlier state, but now we have the services that are funneling to both the areas. Kafka, is doing that. Right. In fact, Kafka is also writing the third to the existing environment. Right. So Kafka is now funneling through 3. Yeah, exactly. So good question. Again, to implement Postgre, Aurora, SQL in AWS is really, really simple. You can get started in matter of hours, actually. So this is how we started implementing. So as soon as we determined that, we wanted to go with Aurora PostgreSQL, right? The left side is the first implementation. So very easy, a few button clicks, and you can stand up your cluster. And you can actually get going with that cluster. Now, the beauty about this implementation is, you can start with when you start, right? Obviously, your throughput on the on-prem environment, at least we did. We knew the traffic that we were going to anticipate in the Postgre Aurora based on our current operations on the on-premise SQL Server OLTP. But, this implementation makes it so easy to start, a simple cluster. So this is how we got started, right? So one of our first thing was stand up a cluster, understand how that operates in terms of schema management, right? So first thing is you set up your schema, you start planning your first payload transition to PostgreSQL to get it operational and start understanding the patterns, right? Write patterns and read patterns, things like that. And then what we did is we then started thinking about, okay, we have to get historical data into the PostgreSQL first in order to shift our operations to Aurora. We had to think about how we'll operate writes onto the Aurora, right? So again, we'll go through more details, but Aurora manages your write and read, writes and reads very nicely. You can actually have your write cluster separated from your read replicas. So all your write traffic is not really hampered by, you know, the operations that are reading the data from the cluster. So we started with the thing on the left, and based on, you know, some criteria that we went through, we implemented, you know, the configuration we have on the right with a reader or with a writer instance and multiple replicas that we now read from. So we have two separate URLs now. Our write, you know, Kafka writes actually goes to the write URL, while we have read replicas serving our reads for the application. Good time check?
Yeah, we're good with time.
Right. Okay. So this talks about our implementation on-premise, right? So as I mentioned, we are currently on a SQL Server OLTP, and then we are moving to PostgreSQL Aurora instance. So I mean, this is again, you know, rather older, I shouldn't say older, but it is the current implementation that has been carried out for certain years, right? So we have, in order to cater to 500,000 or 5,000 customers, we have a sharded architecture currently that we have implemented on our SQL Server OLTP. So we have a few shards that operates all of our clients, right? Depending on, you know, the client base, we kind of route them to a particular shard. And then we have a router, or we call it a hub actually. So that hub directs the traffic, the write traffic most prominently, because we want to make sure that when a write comes in from the device through RabbitMQ, we route that to the appropriate cluster. Same thing is with the reads. You know, when the context comes in as the company, we route that particular read to appropriate cluster. Now, you know, if you think about it, right, we have certain replicas, our business is growing. It's really becoming cumbersome to manage the shards, because the thing is you have to make sure that all of your shards are in sync. So, you know, the deployment can start on one particular shard, and then it has to propagate to, you know, all the shards that you have within the ecosystem, right? So we were looking for an environment where we can, you know, instead of managing, you know, 5 different shards, we can go with one instance. We can scale that instance. So we need a scalable instance based on our throughput. But then it also allows us to get into, you know, like a partitioning strategy rather than a sharding strategy, right? So in a way, it's a win-win situation for us, because we don't have the complexity of managing shards, as well as we get the same throughput with the partitioning strategy. And then one of our evaluation criteria was also the partitioning strategy, and you know, Aurora has one of the really good partitioning capabilities. So, you know, as I earlier mentioned, right, we want to maintain 3 years worth of data on our OLTP system. So, you know, at least we spent quite a bit of time understanding our partitioning strategy, our read patterns, and read patterns were known, so it helped us to devise the partitioning strategy. So we went with, you know, about 36 monthly partitions. Our main goal was to easily drop a partition when we come to that 3-year period, because that data is already captured in our data warehouse environment. So if you really need a longitudinal view, you can always go to our data warehouse systems. So, and then, you know, sometimes, see, these algorithms are very tricky. You know, for example, some of the GPS algorithms, some of the events that we track through the devices, right? So we get false positives, we get noises out of the device as well. Now, sometimes, you know, we get dates that are out in the past or way in the future. So we have special partitions that will capture erroneous data into those partitions, right? So, you know, it's obviously available, but it doesn't hamper your day-to-day writes, which are going through, you know, like a time boundary. Give me all the events for a particular time frame, right? So that scenario is also captured very appropriately here.
So you partition the daily partitions? Or
Monthly partitions.
monthly?
Yes. You know, right, I mean, actually, as this picture suggests, there's a very nice way to organize these partitions in PostgreSQL or in Aurora SQL. You did it? Okay.
That's why you'll see me asking questions.
Okay.
I know what you're talking about.
Okay. No, sure. And, you know, it's definitely fun to talk about these technologies and implementations, right? So, you the thing is, technology is available, but your implementations are what, exactly. So, no good. So again, the implementation that we have now, the cluster that we have designed, we had a great improvement on our write throughput, right? But most importantly, our reads were quite distressed in our existing environment, right? In the SQL Server environment, one of the challenges that we had was it was very hard for us to drop the data. Now, you're right, the current implementations of SQL Server also allows you to partition the data. It easily allows you to drop the partition. But the way we had implemented, we had not had a great opportunity to clean up the data. And that's the reason, like if you go with like a 90-day period of the reads, the system won't, it will crawl actually, and it hardly comes back. We have actually resolved all these scenarios in the PostgreSQL implementation based on partitioning, right? Right. Now, partitioning actually solves two problems for us. One is the management of the longitudinous of the data, as well as easily manage these data sets. You can drop off the partition, age off very easily, right? So it served two different purposes for us. And that's what actually got us involved in it. So it was super exciting implementation. We did a POC, and it is actually in production, and it works perfectly. Okay, yeah. And obviously some of the lessons learned, right? So it's a very typical migration scenarios, right? So first you will have to make sure that, at least in our case, when we are moving from SQL Server to PostgreSQL, right? So data type compatibility is a very important thing, right? So we have to make sure that all of the data types are compatible to PostgreSQL data types. And then, we have some really good tools within AWS ecosystem. We use the schema conversion utility pretty heavily actually when we initiated this work, and that really helped us minimize that effort because we are talking about almost a couple hundred tables that we had to migrate out to PostgreSQL database, and that utility came in very handy. DMS is also something we leveraged initially, and then we had to tweak it, based on some of our implementation. Because again, the data is huge, right? So we had to make sure that we chunk the data as we migrate them to Aurora PostgreSQL. So we had to do some tweaks around that. We had to spend, good amount of time understanding our read patterns so that we can design our partitioning strategies accordingly. And then most importantly, how we can age off the data in the OLTP environment. So that was one of the critical considerations. And then, we had to design the partition management as well, right? So there are utilities or extensions that we use, cron and there's PG partitions. We designed process around that to kind of now manage our cluster. So that's also now in production. The utilities came in very handy. But yeah, that's basically our journey. And I obviously will go through some questions, but I'll hand it over to Chandra to go through some technical aspects of Aurora PostgreSQL as well.
Yeah, but yeah.
Did y'all use Babelfish, or did you go straight from SQL to Postgres?
SQL to Postgres.
Okay.
We haven't used Babelfish. But I think there was a consideration there. Yeah, we use the schema conversion tool instead of that.
We're
Now,
doing that right now,
okay.
which is why I'm here.
Okay.
So yeah, we're doing a combination of it.
Oh, really?
Schema
So,
conversion tool is
okay.
huge in the process, but we're still using Babelfish.
So schema conversion tool, we had a prior experience of that tool migrating our Snowflake instance to Redshift actually. So that came in very handy. We had about 4 years Snowflake implementation that we had to move to Redshift. And that tool extremely helped us out. And that's why, with that experience, we now leverage that into PostgreSQL migration as well. So came in very handy. Yeah, absolutely. So,
Vishal, you have a question?
I have a question.
Okay.
So when you migrated from SQL Server to PostgreSQL, what about applications? Like, is there any application development needed? Like, how much effort you put it on application side?
Oh, yeah. So on the application side, right? So the first thing is, the schema conversion. The second thing was we had stored procedures. So SQL Server stored procedures. We had to migrate to PostgreSQL, right? So that was a big effort, actually, a significant undertaking from us. So those are the two main things. We had some aggregations that we also built using SSIS tools. And that also we are in the process of transitioning some of that, but then, that is one of the big lift that we have to do from our SQL Server migration to PostgreSQL migration.
So I'm asking about like client applications. You said that we have some client users, external users using your database to read some data. Right? Is there any application development your developers doing on your
Yeah. So we have, what is that? We haven't used the Aurora, the RDS version of the ODBC client, but there is another one, NPG SQL or some client library that we have used in order to migrate the reads from SQL Server to PostgreSQL.
Okay, just changing the provider. Right?
Exactly, right. Yeah, because under,
Provider
right,
to
to PL SQL provider.
on the .NET application side, it works.
Right. Now there is another use. What's that?
These are .NET.
.NET apps, yeah. So we are on a .NET stack.
So you are finding a lot of similarities between
Okay.
what pain we are feeling.
Okay, perfect. Yeah, so we are on a .NET stack. The other thing is also there are some APIs that we expose on top of this data that we are also transitioning now. It's not, application interfaces are different, but we also expose this data through our developer public APIs as well. So
So you develop your own APIs,
Yeah.
your own microservices.
exactly. Right.
So we are on the same page.
Okay. Yeah.
So yeah, if I understand correctly, your data is kind of pending to existing. There's not a lot of updating, right?
Well, so, in this particular use case, we have updates as well, right? So what we do is, as we capture the events, right? So for example, let's say if you are driving the vehicle and you're not wearing a seat belt. So our machine vision technology detects that you're not wearing a seat belt, right? It will send you an alert. But if it is a persistent behavior, we define a coaching workflow behind the scenes. And we do both actually, inside behaviors as well as outside behaviors. For example, right, let's say following distance. You're following too closely to your vehicle in front of you. Now, you are capturing the vehicle distance, okay, so there is an event that, okay, you are following too closely, but there are certain parameters like you are 1 second behind, 2 seconds behind, 3 seconds behind. So now you go into identifying the behaviors that are deep behaviors, right? So we get an update to the same record, and behind the scenes, we update the scores actually on how critical that behavior is. So there is a score attached. All of that happens behind the scenes. So there are updates also happening on all these events.
Yeah, are there vectors involved?
No.
Just ask.
Okay.
Let me make sure I understand your migration approach. Schema-wise, you use kind of get help from unknown schema conversion. Data-wise, using get help from DMS.
Yeah, right.
Of course, we cannot do everything.
Right.
And I will cover more in this
Yeah.
upcoming slides too. Okay. So let's, thanks Bhavesh.
Yeah, that's good.
And let's continue this with migration best practices. And yeah, so you might face some of the challenges what I'll be showing in the upcoming slides. But on top of it, if you want to add anything, then please let us know at the same time, because we also want to learn from your experiences. Okay. So the migration best practices, I made it simple and straightforward using a general structure, using a 3 Ws. That means why, what, and who should involve in these migrations. Okay. Simple. So why customers are migrating from SQL Server to Postgres? Can anyone tell the top one reason? Money. Yes.
Absolutely possible.
Yeah. And second reason, especially when moving to cloud.
Because I don't want the helicopter of grades and catching.
Yep.
Exactly. It's a managed
It's a managed service, right?
so that you can take advantage from the capex. From the capex, you can save more money, in fact, okay, apart from the licensing. And since it's on cloud, you can bring agility and you can innovate faster. That means you can spin any instance of your choice for your experiment without procuring these resources ahead. And once your experiment is done, then you can release the resources. It is as simple as like that. Okay. But this is the most common thing, what you heard during the migrations. But the key thing in this presentation I want to highlight here is this one, the business case. Okay. What is your business case? What is the driving factor for this migration apart from the cost and all the advantages of what cloud brings? Is there any problem that you want to address during this migration? That is a key thing that I want to highlight here. Okay. And all hidden things apart from what you see it in the internet. Okay. So let's continue with the other reasons. Okay, especially since it's an Aurora Postgres, you get 99.99% SLA uptime, and you can use serverless global databases, and you can go global in minutes with single push of button, and you can get encryption at rest and at transit. And with continuous backups, because since it's a managed service, you don't need to schedule any backups. It takes continuous backups. And within point-in-time recovery. And a lot of features, like, as Bhavesh covered, every write, it goes to 3 availability zones with 6 copies, where 2 copies on each availability zone. So the storage of Aurora, that brings, with the 6 copies on 3 availability zones, with an write quorum where the quorum for writes is 4. That means it only commits as and when it writes to 4 places. Okay? And the quorum for the reads are 3. And it only allows the reads as and when at least 3 copies are available. So this storage architecture makes the Aurora highly reliable, fault tolerant, and durable. Okay? So that's a major advantage. The storage itself is a major advantage. And apart from it, it has lots of features that includes database cloning and up to 15 read replicas and RDS proxy. And on the right side here, you see how it integrates with the other services. Like with a 0 ETL, it can integrate with Redshift, TKS, Lambda, and so on. Okay? So now, the next one, what needs to be migrated? So the top 3 things that comes into our mind when migrating from one database to another database is schema. And what's the second thing? Data. And the third thing is source code, right? Sorry. Okay. Yeah. So these are the 3 things come. Okay. But before that, before migrating, as I mentioned, like define your success criteria. It is like you need to have a clear definition of done statement, like how the migration should looks like at the end of it. Okay. Here on the left side, let's assume that this is your existing environment at on-prem, and this is your target architecture. I just put it in very simple diagram. Okay. So you should have a clear understanding on definition of done statement and then work backwards. Okay. And here, what needs to be migrated? Here everyone knows like schema, data, and source code. This is common, no need to explain, right? But the bottom line, these are the 3 things that you need to pay attention to. That includes, as Vikas mentioned, some of the things are at the bottom, but there are more. And I grouped into 3 areas. The first one is dependencies. So on SQL Server environment, you might have a lot of jobs. So if those jobs are backup jobs or maintenance jobs, these will be taken care by the AWS. But there could be some application-related jobs or an SSIS jobs or a maintenance, different kind of maintenance jobs, right? So you need to have a documentation on all the dependent jobs in your system because you need to migrate these jobs as well, right? And apart from the jobs, there could be some other external systems like SSIS, SSAS, SSRS, or some other third-party services might be depending on this system. Okay, and I'll give you a very good example. Okay, Like a decade back, we migrated, before joining in AWS, I was working as a consultant, and we migrated one application from SQL Server to Postgres, okay? But there is a third-party service which is depending on this database, okay? But they don't integrate online. They integrate with our system offline. That means every day we take the backup of SQL Server database, and we send it to the third-party services, right? So after the migration, they are expecting a SQL Server backup, but the production is Postgres. So it takes some time to give them a SQL Server backup because they cannot accept a Postgres backup, right? So they have to change the system, which they are not willing to, right? So these kind of hiccups you may face if you don't pay attention to the clear dependencies, whether it is tightly integrated or lately integrated, right? And the second one is the application behavior. So here, let's assume, I'll pick a simple example. Let's assume that your application is heavily used by the users in a particular region, okay? And let's say it's a job search application, and where all your recruiters get used with that application by entering certain keywords, right? But when you migrate it to Postgres, Postgres supports full text search too. And in fact, it even provides much better features than SQL Server because Postgres has PG trigram indexes and PG vector and so many extensions. It even powers more full text search.
Yeah.
But the problem is the behavior, the input behavior is slightly different than the SQL Server, right? See, here the thing is you take advantage of the Postgres using that extension, but at the end, it is changing the user behavior. So can you train all these 5,000 or 10,000 recruiters to get acquainted with the new interface? That takes some time, and there might be some business impact, right? So, but there are workarounds to mimic exactly like how SQL Server behaves in Postgres. There are some workarounds, but you have to pay attention to it when migrating from SQL Server to Postgres, right? Yeah, and also some non-functional requirements. Okay, I'll pick the top example. Let's say data masking. SQL Server has an inbuilt data masking. You can even mask the data even while taking the backup, and you can give it to downstream departments. But in the Postgres, it's a different way to do the data masking. In Postgres, you can use an PG encrypt, and there are some third-party services. And here in AWS, we are working with a different vendor for encryption. Okay, so these things you need to take care because certain things, let's say, let me give another classic example. Let's say cross-region read, okay, the middle one, the cross-region read. Let's assume that you want to go global, okay, but you want, so your database is in one region and your replica is in second region, and you want to implement active-active, okay. So after you migrate to RDS or Aurora Postgres, there is a feature called active-active. Using PG active, you can implement it. But the PG active requires a certain schema level changes because every table should have a primary key, right? So if you don't have the primary key, then again you have to, it's not that easy to implement. But that is one thing that you want to solve. That is one problem that you want to solve after the migration. So pay attention to it and plan. Plan all these dependencies and then plan your migration. Identify these dependencies and then plan your migration. Okay? Okay. And who should involve in the migration? Can you give 3 stakeholders or top 3 names, like top 3 roles should involve in migration?
Business stakeholders.
Sorry?
Business stakeholders.
Business stakeholders. And second one?
SMEs.
Of course, SMEs. And DBAs?
Developer team.
Developers?
Testers.
Yeah. Okay. Yeah, let me highlight few more, okay? Let me highlight few more, okay? So here, so see, this is, on the right side, here is the complete, the most important list of who should involve in the migration. On the left side, this is the copy of the previous slide, right? Schema, data, source code, dependencies, application behavior, non-functional requirements. This is what you need to migrate. And to migrate these things, you need this set of stakeholders. Okay, so the DBA architect, everyone knows, DB developers, full stack developers. But look at below, downstream departments. Okay, let's assume that you migrate your SQL Server to Postgres on production, or Postgres or MySQL on production. And now your downstream departments, such as a risk or analytics or some procurement department, they take copy of this data every day, and they do some analytics and produce a report to C-level executives. Okay, but their entire source code is on SQL Server. Okay, but if you cannot take Postgres backup and restore to SQL Server, but there is a way to copy the data from, again, Postgres to SQL Server. But they said, but we don't do that, because we migrated to production when we will give a clone, a Postgres clone. It's easy, right? Even if the database size is 5 terabytes, or let's put 100 terabytes. Even if a database size is 100 terabytes, using Aurora Postgres, using a clone feature in Aurora Postgres, you can take the copy of the database in 2 to 5 minutes. That's it. That's how the clone works. Yeah. But that is fine. This feature is good. But is your downstream departments are well aware of PL SQL code? See, the good thing with Postgres is, like any other relational databases, it supports standard ANSI SQL. Of course, it's a relational database. Of course, it's an ORDBMS, and it has to support standard ANSI SQL. All databases has to. Okay, but every database has their own proprietary language too. In SQL Server, Microsoft proprietary language is T-SQL. So when you declare a variable, it's not a part of ANSI SQL. It's a part of T-SQL, right? But when you migrate to Postgres, in Postgres, you cannot declare a variable like it's in SQL Server, because that declaring variable is proprietary to Microsoft. But when you move to Postgres, Postgres is a block-structured programming language. So the downstream departments, they can run all select statements, like select, join, insert, update, delete, CTE, views, everything will work, because these are all ANSI compliant. But the moment they touch anything other than ANSI, then they have to keep it in a block. But there will be some knowledge gap, right? They're good in ANSI SQL, but they should know PL SQL up to some extent, right? So it is important to educate them on Postgres. Okay, so that's the reason you should involve whoever is using the system directly or indirect, right? And along with end users. Why end users? Because the classic example I had given, application behavior, recruiters with full text search, right? And compliance teams. Of course, we have to involve compliance teams, whether it is a SOX or HIPAA or whatever the compliance that you need to follow. You have to involve the compliance team to make sure that we are not violating anything. And of course, Aurora Postgres supports all kinds of complaints, right? That's another thing. And the last one. So here, it's a question. So let's assume that you have SQL Server stacks, SQL Server applications and databases. So most of your staff or most of the employees or the engineers are well aware of SQL Server. Okay. So if you hire is it good to hire a Postgres DBA into your team and educate him on your application, or is it worth to educate your SQL Server guys to learn Postgres using their knowledge on SQL Server? Which one is better?
The domain knowledge is not easy. It takes
Yes. Yes. So the domain knowledge, the tacit knowledge, is not easy to translate, right? So it's better to make a cross-database experts, okay? Yes. So for that, we have a program. Okay, I'll show you the program in the next slides. But here, I just want to highlight the top 3 things. Because, see, there are a few differences between SQL Server and Postgres. The top 3, there are a lot of differences, but here, the top 3 differences are, let's say SQL Server is case insensitive, but Postgres is case sensitive. And there are ways to make it case insensitive queries in Postgres. But everyone should be aware of how to make a case insensitive queries in Postgres, okay? Just like that, there are few differences in setting isolation levels, and there are some ways to take backups in Postgres and so on, okay? So to bridge that gap, we have a program called Postgres for SQL Server DBAs, okay? So we delivered this program to Lytx as well, right? And their entire staff now acquainted with Postgres using their knowledge on SQL Server. So within just 2 to 3 days with series of sessions, the staff is well aware of how to write stored procedures, views, functions, and how to convert this thing from SQL Server to Postgres, along with taking help from the SCT. Okay. So if you are looking to learn Postgres using your knowledge on SQL Server, then reach out to us, and we can deliver this session to your team anytime.
For us, it's developers.
Yeah, sure.
It's great. I also do it.
Yeah, and then again, we went through the same scenario. I mean, we had developers in the session, one session, then we had another session for the rest of the folks who are using SQL against the data sources, and then DBAs also went through. Since we are SQL Server implementation, we have a DBA team that, yeah.
Nowadays, it's a very small shop.
And
We are not a large.
right, and as Chandra mentioned, we are cross-training them on managing both environments, which is, yeah, it's a learning curve, but
Is the charging is good?
yeah, that is good.
Okay. Okay. Yeah. So through this program, we will cover everything. Based on our lessons learned in migrations, we identified 16 topics that are most important for the SQL Server developers to know before migrating to Postgres. Okay? All right. All right. So now, let's explore the other tools what we have to support these migrations. Okay. So now, this is the standard one. Okay. So once you analyze by identifying who, what, why, then start off with converting the schema, and then migrate the data, migrate application code, and test every single feature, and then go with the final cutover. Okay. So my recommendation is you collect all your requirements and start off with a pilot migration with minimum data, right? Yeah, so that's the best way to do it. Okay. A POC, a proof of concept, okay? And here we have the list of tools I want to highlight here, top 3 tools. The first one is a Fleet Advisor, DMS Fleet Advisor. Let's assume that you have 2,000 SQL servers in your environment. Let's assume that there's a large enterprise and they have lots of SQL Server databases and Oracle databases. And they want to identify how many database clusters in their environment. Okay. So we have a service called Fleet Advisor. You just have to download this tool and run this tool with some credentials, and that scans your entire environment, and that produces an HTML report. And it uploads the data to an S3 bucket, and then it produces a report, and using the report, you can see how many SQL servers or how many Oracle or MySQL databases in your environment. Okay. It gives the list of the operating system, clusters, and the database clusters, and the list of the schemas, and list of the common schemas. This is important. Let's assume that you are migrating an ISV application, and that database has let's say that database has 5,000 schemas where 4,000 schemas are common. Then you don't need to analyze all these 4,000 schemas, right? You only need to pay attention to only one schema, right? So this Fleet Advisor really helps to review your environment and give some insights. And it also gives some insights on what kind of clusters you should provision based on the performance metrics, because it also gathers some performance stats from your environment, and it will suggest the right instance on AWS. That really helps, because it saves a week's worth of your time, and it gives something to start off with.
So do you have to install that on a separate EC2 instance, the DMS Advisor?
This one, the Fleet Advisor? Yeah. First, you have to configure Fleet Advisor at the AWS console. I'll show you in the next slide. Yeah. And download the tool and install it and run it. It automatically collects and push it to S3 bucket.
No, but where am I running it? On my laptop? Or am I installing a new EC2 instance where it will run?
No, in your on-prem environment with the domain credentials.
I know, but everything is in cloud, in AWS cloud. There's nothing outside it.
Oh, okay. In that case, this is to identify your existing in your on-prem. Yeah.
Yeah, but
Yeah.
no, we ran it on EC2, right? So schema conversion tool, yeah.
Yeah.
Right.
Yeah. Yeah. No, his question is about Fleet Advisor, right?
Yeah, I'm asking about Fleet.
Yeah.
Yeah. Fleet Advisor, it's at on-prem. This is to discover your on-prem to migrate AWS. Yeah.
Put it in the VM or something.
Yeah.
Footprint.
Yes. And the second one is the schema conversion tool. The schema conversion tool, using schema conversion tool, you can get some estimates on how much effort it takes to migrate from one database to another database, and it also converts some of the source code to target database. Right? Yeah, and yes, and as he covered, yeah, schema conversion tool, and which is free. You can download and you can convert and you can come up with some estimates to start off with. Yeah, right. Yeah. And to migrate data, you can use DMS. And yeah, sorry.
One EC2 instance for the DMS.
Yeah, for DMS you need one EC2 instance, called as a DMS instance, yes. So to migrate data, you can use DMS, especially for heterogeneous migrations. So these are the top 3 tools, and along with this, you will get support from us. So we have solution architects, we are the solution architects, and we will support you in your migrations by providing guidance, training, and whatever that you needed. Along with this, we have partners, in AWS approved partners and professional services who can help you in your migrations. And also a DMA program with a list of advisors who can guide you on with the different migration options. And along with this, we also have programs, start off with MAP. So the MAP program helps you to optimize your licensing. They will guide you on how to optimize your licensing, especially if you're coming from SQL Server or Oracle. And along with this, we have database freedom and best practices, playbooks, and DMM. That means a database migration accelerator. So this program is specifically for the heterogeneous migrations. Yeah. So we have several programs.
No, I was just about aware of the database freedom.
So yeah, you can reach out to us and we can point to the right team. Right? So this is in a very high level. So how does Fleet AWS works is, on your on-premise data center, it uploads the data to data collector to an S3 bucket, and from S3 bucket, it produces a report, kind of an HTML report. So using that report, you can assess how much effort it takes and what kind of resources that you need to spin on AWS. Okay? Right. So this is about the Fleet Advisor. This is like a discovery. Okay? And SCT, this is to convert the schema. Right? And the high-level steps. Use the SCT and migrate your DDL, that includes views and views, procedures, triggers, and all other objects. Right? And then migrate data, because DMS supports initial full load, following with replication, following with a continuous change data capture. Yeah. Okay. Following with a continuous ongoing replication. Okay. Yeah. Yeah. So, and the high-level steps to implement DMS is, it's very simple. You just have to create a replication instance and connect to source and target, and create a task. The task is to migrate the data, just like SSIS. Yes. Right? And select the tables that you want to migrate. And then once the target is caught up with the entire data, then you can switch the applications to target engine.
So how long will that take when you have, like, you mentioned 30 gigabytes or whatever? How long will that?
Those numbers, it varies. Why? Because it depends on your size and the type, and basically size and type of data. Because if you have a blob data type, that takes a different amount of time. And how narrow the table is and how many number of rows in the table. And also your replication instance size, right? And also the network. Yeah, if you're in a direct network, yeah, if you're in a direct connect,
Install a pipe, private pipe
yeah.
to high speed.
Yeah, direct network, direct connect. Yeah, direct connect. Yeah, yeah, if you use direct connect, if it's in the same environment. Okay? Yeah, so this is all the lessons learned that I shared with you. Most importantly, the hidden things. And I hope this helps. And as I mentioned, we do want to learn from your experiences. So share your experiences if you are migrating from commercial to open source engines. We are here to learn and listen.